And let me show you an example. I'm going to write a class and point out some problems, and then we will refactor that using polymorphism. Okay, so let's get started here. I'm going to share the screen. I have a project here. I'm using IntelliJ IDEA. This is the community edition. I'm not using Eclipse because this sometimes helps me write code more quickly. So let me go ahead and create a Java class. I don't know if you can see this particular interaction where I am creating the class. I'm creating a class named video source. So here is the class video source. So this class represents a piece of video. So the video would be stored in an array of integers. A video is nothing but a sequence of bits, right? So you can store everything as integers. So let me call it video info or something. Okay. So when you create a video source, you are going to specify the content of the video that actually contains the video information. That is what you play. But then this video could be put on different kinds of devices. So I'm going to also store the device type. Where is this video stored on? So I'm going to have several fields. One is if you are interested in very old types of stuff like tapes. I don't think anybody watches VHS cassettes anymore, but anyway, a tape would be one possibility. The second possibility would be, say it is on a USB. Third one might be hard drive. A fourth one would be DVD. And let's put one more. That is what you and I do mostly these days is streaming, right? Network streaming. Oops. So there are 5 possible devices or schemes or types of storing the video. It could be on a tape, it could be on USB, it could be on hard drive, etc. And this will remember whether it is the tape or the USB or the hard drive or the DVD or the stream, right? So I'm going to create a constructor here. So here is the constructor. When you create a video source, you supply the video information, the actual content, and also where it is being stored. Now, we could write a main method here. Let me see. I don't know whether I can generate a main method through this one. Probably not. So I would write stuff like this: video source equals new video source. I need some, let me say, int video file equals new int 1000. It may be a short video, doesn't matter much. I'm not having anything there anyway. And I would say things like video source dot DVD. So I create a video source object. I'm supplying the actual content, and I'm saying that it is actually stored on DVD. And this is not going to be useful unless you can actually play the video. So I'm going to play the video after supplying the video information and the fact that it is stored on DVD, which this object remembers in these two fields. I'm going to have a method called play. So this will play the video, but the mechanism for playing would be different for playing from tapes, from USBs, hard drive, etc., etc. So I'm going to have different methods for that. Void play tape. And I have I'm going to create one method for each one of these types. Of course, I'm not doing anything substantial in these methods because I really don't know how to play these videos. So I'm going to simply write a one-liner saying, I want to play the tape or the DVD or whatever. Play USB. What else? Hard drive. Maybe I should write using or something here so that it's a little makes a little more sense. And here, stream, play, or stream the video, or streaming the video. Okay. So there are all these different methods here to play the different types of devices. And the idea is that I will be calling the play method, and the play method will have a conditional. It would look at the type, the device type. If it is equal to tape, it will invoke play tape. Else, if DVD hard drive, then USB. Oops. Okay, so that is what happens. If you call the play method, depending upon where the video is stored, it is going to invoke different methods here. Okay, so here I created a file, a video file on DVD. So if I write video source dot play, it will play the stuff using DVD because device type is DVD. It will go here and then call the play DVD method, and I should actually get this message. Let me try this. Okay. All right, I need to change my run configuration. Test. Yeah, and it's displays play using the DVD. Okay. Do you follow the structure of the class, how it works? Anybody having questions? Anyone?
What did you say?
Any questions about the structure of the class, how it works, what it does, anything of that kind?
I was just curious, is this the kind of like the replacing conditionals with polymorphism?
Yeah, that is where we are headed, yes.
Okay.
So anything else at this point? So we have a class called video source. We store some data, that is the video information, and then we store the type of device where this video file is stored. And there are 5 possible devices. And all that information is created or stored along with the object. So a video source object knows what the video is, what the content is. It also knows how to play, what device it is. So depending upon the device in which it is stored, it does different things. So this is how it is structured. You store the type of the device here, and based on the type of the device, we switch. We have 1, 2, 3, 4, 5 places where we are checking what type it is. Well, it works. There is no doubt about it. But the question is this the way that we want to construct our systems? Well, every programming paradigm has its own style of doing things. We have the imperative paradigm where you have programming languages like C or Pascal or those kinds of things where we program in one style. In the object-oriented paradigm, we use a different style, and there we don't use conditionals like this. Of course, we have to use if statements and switch statements and so on, but not for these kinds of things. If we are doing different things based on the value of a field, then it is time to examine. Maybe we have different kinds of objects here. The central idea here in the object-oriented paradigm is that of an object. So we don't have many types of objects here. There is only one object type, that is a video source. Whereas this implies that there are different types of objects. So what we are seeing here is, depending upon the type of device, we are having this object exhibit different behaviors. So the behavior is dependent on the type. So the behavior of the object is dependent on this field. If that is the case, it is time to replace these conditionals with polymorphism. What do we mean by that? We must have different kinds of video sources. And that is actually implied here, right? Video source can be of different types. So we create additional classes that represent the different sources. We know that there are 5 different video sources: the tape, DVD, hard drive, USB, and stream. So instead of having a conditional, we will have a superclass, which we can call video source or video or something like that, and subclasses to represent each type of device. So instead of having just a single class, we will have this as a superclass and 5 subclasses. So we will create one subclass for each of these. For example, hard drive video, maybe not the best of names, but so this object represents video on a hard drive. So we will say that it extends video source. Okay, I'm getting some errors. We will fix all that in a second. So hard drive video is one type of video source, and video source has video info and device type. We no longer will have this device type. Okay, and we will still need the video information. The device type is going to be actually the different classes. So this we will actually make. We could make this protected if you want, okay, so that it is available in the subclasses. And we are not going to ask for the device type anymore. Okay, we just need the video file. So the hard drive video will have a constructor. It is complaining because the constructor isn't right. Now it is correct. I created a constructor which gets the video file and it supplies it to the superclass, and the superclass stores it. Now I don't need this hard drive type here. That goes. That is already in here. That information is already in the object. The object itself says, I am the hard drive. So there is no need for a separate field to say what type it is. And I said we are going to replace conditionals with polymorphism, and the conditionals are all here. So it is, as you can see, it is switching on the device type. We are going to get rid of all these conditionals. And at this point, I can simply make this abstract. Okay, if I have an abstract method, and it is complaining here because I have to make this class abstract. Okay. And there is a problem here because this is an abstract class. I can't instantiate it. Okay. So we don't need any of these things. We have to get rid of all the type information. We are only storing the video information here. And there is an abstract method called play, which plays the video, but this class doesn't know how to play it because it doesn't know what type of device this video is stored on. So it is for the subclasses to decide how to play it. So
would we have to have a class for each of the individual device types?
correct. Yeah, and sometimes you may also have to create this class because this whole thing may be somewhere else, in which case you will have to create the superclass too. But here the superclass seems to be appropriate. This video source is definitely the superclass. So you're absolutely correct. We will create one subclass for every leg of the conditional. Any other questions I can answer at this point?
So would that way be more efficient than doing it like this?
Which way?
So would it be more efficient to have them all in different classes in general, or doing it like this?
That is the best structure. Object-oriented systems are not known for speed, but they perhaps, I mean, this one can argue, I think, represent real life better because we are viewing everything in terms of objects, and you take care of an object and then you simply, or you take care of all the objects and then you simply need to hook them up to get your system working. So every object knows how to behave. That complete behavior is encapsulated within the object. For example, the hard drive knows how to play itself. It doesn't have to ask anybody. See, the way of playing a hard drive video is completely within the hard drive itself, because the hard drive knows how it is structured. Nobody else knows how a hard drive works, but the hard drive knows. So to play the video is the responsibility of the hard drive. I don't know if that makes sense. So what we will do is we'll copy this and create all the subclasses. Okay, let me see. Tape video. Excuse the phone call. Then the next one would be USB video. USB, then Next one is tape, then DVD. And then one more. Okay, so we have 5 different classes. I have some spelling errors here, doesn't matter much. DVD video, hard drive video, stream video, tape video, and USB video, one for each source. And I don't need any of these methods anymore. So there is a play method that is abstract, and it is implemented in each one of these subclasses. So every class is representing a different type of video object, or it is a medium, and it knows how to take care of videos stored there. So you are not, for example, in the DVD, asking others, how do I play DVD? All that information is known to the DVD class, the DVD video class. That is the advantage of doing it like this. There are no conditionals anymore. That switching, that conditional that was based on the actual type of video is gone, right? And we can write a test program. Let's call it test. And let me create a video source. New DVD video. Of course, I need an integer variable. And I will pass that over here. And I can write video source dot play. Let me go ahead and make sure that this will work. Run. All right. So I will run this now. And it says play. Forget the grammatical errors here, but it says playing using the video or using the DVD. That is essentially what it is saying. So I created a DVD video object. You can see that this is a polymorphic assignment. Video source, this variable here is of type capital video source, capital V video source, and DVD video is a subclass of video source. So any object of this type on the right-hand side is of type video source. And video source is polymorphically assigned a value, a reference. So the actual type of video source is DVD video. The declare type is video source. And if you call the play method on this object, it will use the actual type, which is DVD video, and go to this particular play method and play and it will play using that particular medium, right? I could do other thing. Video source equals new, let's say, stream video. And this will play using the stream. Let's run this. See, it played using the DVD, then it played using the stream. So I can polymorphically assign different kinds of objects to video source and call this method play. The actual play method used will depend on the actual object. So there are 5 different possible play methods. The actual method used depends on the actual type that is stored here. That is the plan, and that is what is happening here. You could, of course, in stream video, you could say, I want to also have my own fields. You could have something like network speed or bandwidth or whatever. And I could have a variable parameter, and this dot right. And in my test, I will also supply some number like this, story saying this is my speed. Okay. So I can have my own fields here. You could say, I don't know what special things for a DVD you can put. I'm sure you can invent some stuff here. You could probably say what size, I mean, capacity or some such thing, you know. You can have all those different fields that are unique to each one of these classes in the subclasses themselves. The common stuff should all be in the superclass. So this has all the common stuff. Okay. And you might want to make this protected so it is easier to access that field in the subclasses. Or you could make this private and then have getters and setters. So this is an important topic. How do you convert from a set of conditionals into a bunch of classes? You will increase the number of classes, but that is what object-oriented systems are all about. You represent stuff using different classes, right? You'd like to minimize the number of classes, but not at the expense of having conditionals. Yes, somebody had a question.
Yeah, what if you have an equals method?
Oh yeah, you could have equals method, yes. You could put that in the superclass, you could put those in the subclasses too. When do you want to consider two things equal? Maybe if the video files are the same, then you could consider them equal. Or do you also want to say that the types have to be the same? I mean, so you could put the equals in the superclass, you could put equals in the subclasses as well. You could override them in the subclasses, yes.
Thank you.
Any other questions? This is very important. There is a question about this in the class exercise. There will be a question for you to convert from conditionals into polymorphism in the second exam. So learn that. I mean, I don't mind saying that there will be a question. The reason being, I want you to learn how to do it. And you must get rid of all the type related information. I got rid of all those static fields, the field that stored the type. None of that should be here anymore, because the type information is actually captured in the fact that you have different classes. You don't need any conditionals, because polymorphism will take care of calling the correct method. It's the same play method. Now, there is one more thing I wanted to say before I wind this up. I don't need to have this abstract. I could put some common stuff over here. I mean, assuming you had some, I don't know what it would be, but assume that there is some common code for all the play methods. Put that over here, and then you can call that super dot play. So you can put that in the subclasses. You can call these methods, call that method from the subclasses.
I have another question. Does the video info have to be in an array? Or can it just be a string?
Yeah, this is what you would typically do if you had to store bits. You would have an array of integers. But that is, of course, unimportant in this context. But that, I mean, in the sense, that is not what we are really focused on, but that is what you would do. If you had video information, you can put it as an array of integers. Yes. There is no array of bits in Java. You can store stuff in units of 32 bits, right?
So if you're storing a string,
you don't store it as a string, no. You may store the title of the movie or the video as a string, but the individual bits themselves, see, it would be like this, right? Some arbitrary sequence of, I mean, this would represent video information, and it would be very hard to figure out what the characters for these would be. So it would be pretty much impossible to represent this as a string. Whereas you can take each chunk of 32 bits. I don't know, I mean, let's say we have 32 bits here. Let's assume, pretend that would be the first element of the array. If this is another 32 bits, this would be the second element of the array, and so on. Does that make some sense? Each integer in the array